All right, this is 12.1, day number 2, lesson on coterminal angles, angular frequency, and velocity. Let's get started. What is a radian? Write down a definition of what you think a radian is. Pause the video, come back. So a radian is one radius length from a circle stretched along the edge of that circle. It's about 57 degrees, and I'm not quite sure what we meant by this third bullet point, but I do want to sketch one. So here's a circle. That's hand drawn, by the way. Here's a radius. So if I were to stretch that radius along the edge of the circle, same length, right, that would be called 1 radian. Conveniently, if I were to do that 3 times, right, here's the first radian, let's call it the second radian, and the third radian. It's just a little bit short of half the circle, which, conveniently, is 3.14 radians, which is pi. That is so important, I cannot emphasize it enough. So, gains. Next slide. All right, I'd like you to pause this and attempt these 2 review problems. Welcome back from that pause. 2 formulas that you need to know are that arc length S equals r theta. Okay, so arc length S equals radius times angle. And the other one we're going to need to know is area is theta over 2 r squared. So in the circle given, you'll see that r is 4. And if you convert 45 degrees to radians, that'd be pi over 4. Recall that if I wanted 45 degrees converted to radians, I would multiply by pi over 180, because there are pi radians in 180 degrees. So the arc length, S, would be r times theta. Looks like we get pi units. That's U for units. Okay. The area of the sector would be theta over 2 r squared. So if you were to simplify that, you would get, it looks like 2 pi units squared. A little simplifying on that, a little bit of algebra. Okay, second example. Here we'll see that r is 10, and theta would be 120 times pi over 180, which comes out to be 2 pi over 3. Arc length ends up being r times theta, so 2 times 10 is 20 pi over 3 units. That's chicken scratch for units. The area of the sector would be 2 pi over 3 theta over 2 times r squared. And if you simplify that out, you'd get 100 pi over 3 units squared. Cool. Review. Let's keep going. New material. Here we are. We're going to talk a little bit about standard position for angles. Standard position for angles, they always start, their initial side is on the x-axis. And then those standard angles are going to rotate to a terminal side. So this would be the terminal side where it finishes. Okay. Positive angles rotate counterclockwise. Negative angles rotate clockwise. And coterminal angles, vocabulary term, coterminal angles, they terminate at the same spot. So they have a common terminal side. So in this case, 120 and 240, negative 240, are coterminal angles. Let's look at a couple of examples here. First, let's take 60. So I want you to think, how in the world would I find another coterminal angle? Well, I'd have to take another full rotation. So imagine this, right? I'd have to take a full rotation from here to here to get the next coterminal angle. And that angle would be positive because I'm going to be adding 360 degrees. Another coterminal angle the opposite direction would be subtracting 360. So in this case, what I'm going to do to find my positive and negative coterminal angles is I'm going to add 360 and I'm going to subtract 360. And if I do that, what do I get? Well, it looks like I get 420 degrees. And I get negative 300 degrees. Okay, a positive and a negative coterminal angle, all which would have the same terminal side. Okay, so in letter B here, or number 2, and the angle is beta now. Here's our negative coterminal angle, right? Terminates here at this side, negative because it rotates clockwise. So that's negative 225. If I added 360 to that, I'd get positive 135. Let me demonstrate what that would look like. There is a coterminal angle. That's 135. I'm also going to subtract 360, which would give me negative 585. Let's see what negative 585 would look like up here. Okay, so I'm going to start here. I'm going to rotate. I've rotated negative 225. I'm going to rotate another 360, and that would be negative 585 degrees. Okay, let's continue. If you want to pause the video and go to the next one and give it a try on your own, feel free to. Otherwise, I'm going to just continue. I'm going to take 540, and this is where it's going to get kind of interesting. Gamma equals 540, and I am not going to add. I'm not going to add 360. What I'm going to do is subtract 360 twice. And the reason why is because on the way, I will get a positive and then a negative. So if I subtract 360, I'll get 180. And if I subtract 360 again, I'll get negative 180. So I get my two coterminal angles, one positive, one negative. Here would be positive 180. Okay, that's positive 180. And here would be negative 180. Excellent. Last one. This is the Greek letter phi. Phi, and phi equals, looks like negative 750. Now, there's no reason that I should subtract. I'm not going to do that. I'm going to add twice, and in this case, I think I have to add 3 times. Because if I add 360 once, I get negative 390. I add 360 again, I get negative 30. So I haven't gotten my positive coterminal angle yet, but I'm going to on this one, where I get positive 330. So I would probably, if I were you, I would do these two angles just to keep it simple. So negative 30 would be that angle. And it looks like positive 330. That wasn't very symmetrical, but that would be positive 330. And there you go. You've got coterminal angles that are all 30 degrees from the horizontal x-axis there, positive x-axis. Let's keep going. All right, if you want to pause the video now, we're going to do this same process except in radians. All right, so in radians, I'm going to take my first angle, which is pi over 6. And instead of adding and subtracting 360, now I'm going to add and subtract 2 pi. But I don't want to add and subtract 2 pi because I'm going to have to think about common denominators. So I'm going to add and subtract 12 pi over 6. Pause the video. Think about why I'm doing that. Okay, you're back. Why would I do that? Because 12 pi over 6 has a common denominator with pi over 6 and is equivalent to 2 pi. So if I add 12 pi over 6, I get 13 pi over 6. And if I subtract 12 pi over 6, I get negative 11 pi over 6. So let's sketch that on the graph above. 13 pi over 6. Okay, so a coterminal, positive coterminal angle with this would be 13 pi over 6 Think about that. That's 12 pi over 6 plus one more. That'd be 13 pi over 6. The other way, like we said, was negative 11 pi over 6. So if I rotated here, almost negative 12 pi over 6, that's negative 11 pi over 6. Again, clockwise is negative, and counterclockwise is positive. All right, let's do a couple more here. I think I'm going to do, let's see, I'll go with gamma, problem number 3. How about that? So let's take 9 pi over 4. Gamma equals 9 pi over 4. And I'm not going to add, right? I'm not going to add because that's going to give me a larger positive. And if I just subtract twice, I'll get 2 positives. How do I know that? Well, I know that because this number right here, 9 pi over 4, is greater than 2 pi. So if I subtract 2 pi from that, it's still going to be positive. Okay? So take your angle, initial angle, and see if it's greater than 2 pi away from 0, whether it's negative or positive. So I'm going to subtract, and when I subtract, I get pi over 4. What do you mean? You subtracted 2 pi? No, I subtracted 8 pi over 4, right? Because that's equivalent to 2 pi. Okay, and I get pi over 4, and then I subtract another 8 pi over 4. And I get negative 7 pi over 4. So those are my two coterminal angles. I'm going to sketch them right quick. Here's pi over 4. Counterclockwise is positive. Here's negative 7 pi over 4. And we're solid. Let's keep moving on. Okay, this would be pretty much what we just did. I'm going to give you the two angles. I'm going to add and subtract 360, which would give me 570, and would give me negative 150. The question here is asking what quadrant would that be in? Well, if you're not familiar, this is quadrant 1, 2, 3, and 4. So if I were to take 210 degrees, that would be right about there. Right, that would be in quadrant 3. All right, let's do the same thing now in radians. This is larger than negative 2 pi over 6, right? Negative 12 pi over 6 would be negative 2 pi. So I am not going to subtract. I'm only going to add. So I'm going to add 12 pi over 6 twice, and maybe even 3 times if I need to. But I'm guessing in this case, yeah, I don't need to do it more than twice. So negative 13 plus 12 is negative 1 pi over 6. I add it again, right, and I get 11 pi over 6. So let's determine what quadrant those two would be in. Let's do it on the same quadrant drawing here. I'm going to go with negative pi over 6. Hey, look at that right there. That's going to be in quadrant 4. Cool. All right, here we go. All right, now we get to this idea of angular velocity, or velocity for circular motion. Okay, frequency, as you see right here, frequency is just number of cycles over number of seconds. So let me get into that here and see if we can make sense of that. So number of cycles is just distance, and distance is distance along the edge of the circle, which is arc length. Time is t. So let's get into this first one here. Okay, so if velocity equals arc length over t, how in the world would I find arc length, and how would I find t? Well, we're going to take the circumference, right? Because it says it looks like we go 1 revolution per every 3 seconds. So distance covered is 1 revolution per every, 1/3 of a second. But what is 1 revolution in units? Well, that's going to be the circumference of the circle, right? 1 revolution. Circumference comes in 2 forms, 2 pi r and pi d. Which one would be useful here? Well, it looks like the first one because we have r. So what would that be? That'd be 2 times pi times 0.45. 2 times 0.45 is 0.9. So our velocity in this case is 0.9 times pi over 1/3, which is equivalent to 0.9 pi times 3, right? The reciprocal of 1/3 is 3. And 3 times 0.9 is 2.7 pi. That would be in, I believe it's meters per second. If you wanted an actual numerical answer as opposed to this exacted answer, including pi, you could write out to 2 decimal places, 8.48 meters per second. That's angular velocity. All we're finding is distance over time. Let's do an example here with what you call in science class, what is that? Where you're changing units, you're converting dimensional analysis. Is that what you call it? Yeah. Okay. So let's take first this. 2.25 is the diameter, right? 2.25. So when we get to the point where we're using circumference, we're going to want to use pi d. Okay. We know that the yo-yo is spinning at 4,500 revolutions per minute. The end result that we want is some number of miles per hour. So we're going to have to do some dimensional analysis here. But we do need to know how far one revolution is. Well, one revolution would be the circumference per revolution, right? So you could probably already see it. This is going to cancel with that, and then we're going to get distance over minutes, which we want to be distance over hours. So we got to figure out what the circumference is, which is pretty simple in this case. It'll be 2.25 times pi, right? Pi d, pi times diameter. Diameter was 2.25. So that would be the distance traveled per revolution. So right now, we would have, what is that, inches per minute. We want miles per hour. So what we want to do is we want to get rid of inches, and we want it to turn into miles. Well, 1 mile is equal to, maybe you knew this, maybe you didn't, but 63,360 inches. Okay? And we also want hours, right? Because that'll help us to cancel inches with inches. Well, there should be an inches there, but there's not. We also want to cancel minutes, right? Right here, with with minutes, so we get hours. Right? So how many minutes per hour? It'd be 60. 60 minutes per 1 hour, and therefore we can cancel minutes. And dimension-wise, we'd have miles per hour. You can pause the video, do a quick calculation, come right back, and I'll have an answer for you. It looks like rounding to 2 decimal places, our velocity comes out to be 30.12 miles per hour. So guys, that's velocity, that's coterminal angles, that's angular velocity, all sorts of good stuff. You could get into your homework here and enjoy.